Okay, so with that introduction in mind with weak acids and bases, knowing Ka and Kb and how to convert between them, now we can talk about finding what's the pH of a weak acid solution. And we can take the same approach and apply it to a weak base. So we'll just do this again generically at first, and then we can look at some specific examples. So we'll have our HA dissociating into A minus plus H plus. And similar to what we looked at the beginning of the chapter, right, there is a second equilibrium we need to worry about, which is the dissociation of water, the autoprotolysis. But we can make a simplifying assumption here. We can say we can ignore this equilibrium and say that most of the H plus, and more than most, like all the H plus, let me rephrase that, all the H plus will come from the weak acid. This simplifies our calculations and is a very good approximation as long as your concentrations aren't very small, like we saw at the beginning of the chapter. And so for most normal situations that we'll be dealing with, this is a good assumption. So then we only need to worry about the equilibrium with HA, right, this expression here. So then there isn't any other source of H plus we have to worry about. So we can set this up as an ICE table if you're familiar with that. What's the initial change in equilibrium? So let's say we initially start with some concentration we'll call F, the formal concentration of HA, and nothing for the A minus and H plus. And this is our assumption, right, is that we can ignore any H plus from the autoprotolysis of water. Some amount of that F will react, or will dissociate, and we'll get the same amount of production of A minus and H plus. So at equilibrium, we'll have F minus X, X, and X. Now we can go ahead and plug this into our Ka expression. We'll have X times X at equilibrium divided by F minus X. And just a reminder here, F is the concentration of HA that was prepared, right? And so this gives us a nice Ka equals X squared over F minus X. And so this is a solution. We can solve this now, right? As long as we know the concentration of our weak acid, we can plug that in for F, and we just need to solve a quadratic equation, and we can find a final answer. There is one simplification even more that we can make to this. It depends. Sometimes we can make this, sometimes not. And the question is basically this denominator here. Basically, if X is really small, then F minus X is going to be about equal to F. And that can simplify this expression even more. We can end up with Ka equals just X squared over F, and then you don't even have to worry about the quadratic formula. But in general, this is not necessarily an approximation we can make. I think in your textbook it says if the dissociation, basically if you do it this way with the approximation, and you get that X is not really small, and then this is a bad approximation. So this expression up here will always be true. This expression here is a further approximation that you can sometimes make. But in general, if you want to play it safe, just use this one. You'll always be correct using that one. Okay, so that's how we do weak acids. Weak bases are very similar. And what I should say is when we solve this, what we're going to get is X, which is equal to the hydrogen ion concentration. Right, that's what we define here. And so from that, you can find the pH. Okay, when we're looking at weak bases, we can set up the same thing. So B plus H2O in equilibrium with BH plus OH minus, and set up an ice table. Right, we're going to have F, 0, 0. We can ignore water for all of this. We'll have a minus X plus X plus X. And you can see we get the same sort of expression. The only difference here is now this will be KB. We'll still have x squared minus f minus x. And the other key here is that when we solve for x, we're not solving for H plus directly, we're now solving for hydroxide. So then once we find the hydroxide concentration, we can use that to find the H plus concentration with the Kw expression and find the pH. Or we can find POH and find pH from that. Either way works. So we will look at a example problem of doing this in the next video.